Intro. Today, we're diving into the mysteries of technologies that may have appeared far too early, inventions and artifacts so advanced for their time, they challenge everything we thought we knew about history. Were they the product of forgotten civilizations, ancient genius, or something else entirely? Let's explore the strange and fascinating world of technologies that were simply too advanced for their time. The Nimrud Lens. In 1850, amid the sun-bleached ruins of the Assyrian city of Nimrud, British archaeologist Austen Henry Layard unearthed an object so small and seemingly ordinary that, at first, it drew little attention. It was a polished piece of rock crystal, oval in shape, no larger than the palm of a hand. And yet, over time, this object would come to occupy a curious place in historical debate, one that continues to challenge assumptions about ancient technology. This was the Nimrud Lens, an artifact dated to around 750 BCE, and perhaps the earliest example of optical engineering known to history. The lens itself is modest, just under 4 centimeters wide, with a slightly convex surface that gives it the ability to refract and focus light. It is not a perfect lens by modern standards, but it does exhibit basic magnification properties. When placed over a surface, it enlarges what lies beneath. When held to the sun, it can focus light to a burning point. And when examined closely, it reveals traces of craftsmanship, as if someone nearly 3 millennia ago had purposefully ground and polished it into shape. But why? That is the enduring question. At first glance, the object might appear to be no more than a decorative item, perhaps an ornament embedded in furniture or ceremonial attire. That interpretation is easy, even comfortable. It fits neatly within what we already expect from the ancient world. But it also fails to explain the optical precision, however crude, of its form. The fact that it functions unmistakably as a magnifier complicates the narrative. If this was mere jewelry, why shape it to behave like a lens? And if it was crafted to bend light, what purpose did it serve in a society that, according to our textbooks, had no known understanding of optics? One of the more conservative theories suggests that the lens was used as a fire starter. This idea is not far-fetched. Ancient civilizations, from Egypt to China, had discovered that certain polished stones could focus sunlight enough to ignite tinder. But while this may explain how the lens functioned, it does not address the implications of its form. Fire-starting stones do not need to be carefully curved or polished. The lens from Nimrud, by contrast, bears deliberate shaping, as though someone knew that curvature mattered. And so we are left with more provocative possibilities. Perhaps, as some have suggested, the lens was used by Assyrian artisans or scribes as a magnifying aid. This would imply that ancient craftsmen, responsible for the delicate etchings on clay tablets or the intricate carvings in cylinder seals, had access to tools that enhanced their vision. The mere idea that someone in the 8th century BCE might have held a primitive magnifying glass to examine fine details is enough to stir the imagination. It suggests not only technical capability, but also a curiosity about perception itself, a desire to see the world more clearly, to peer closer into its intricacies. But the theories do not stop there. In the more speculative corners of historical research, some have proposed that the Nimrud lens may have been part of a rudimentary telescope. The Italian scholar Giovanni Pettinato once posited that the Assyrians, using a series of lenses, might have constructed devices capable of celestial observation. It is a thrilling idea, but one that teeters on the edge of fantasy. There is no physical evidence of telescopes in Assyria, no tubes, no arrays of lenses, no diagrams or writings that point to such an invention. And yet, the temptation to believe is hard to resist. After all, the ancient Mesopotamians were keen observers of the heavens. Their astronomical records were astonishingly precise. Could they have been aided by tools we no longer possess? Skepticism is warranted, of course. Extraordinary claims require extraordinary evidence. But the very existence of the Nimrud lens invites us to widen our perspective on the capabilities of ancient peoples. Too often, history is written as a linear progression, with knowledge unfolding in orderly stages, one discovery stacked atop the next. But the past is rarely so tidy. Technological insights can be born, forgotten, rediscovered. Ideas can leap forward in one era and vanish in the next. Sometimes, what we call progress is simply the reawakening of something once lost. What makes the Nimrud Lens remarkable is not just what it is, but what it represents, a silent challenge to the assumptions we carry about ancient minds. It suggests that the people of Assyria, with their ziggurats and cuneiform, their myths and mathematics, may have glimpsed deeper into the nature of light and vision than we've allowed ourselves to believe. Whether used to start fires, examine tiny inscriptions, or, in some distant dream, to study the stars, the lens is a whisper from the past. Not loud, not boastful, just a curved piece of crystal, buried in dust, waiting for us to wonder. Damascus Steel. It begins, as many great mysteries do, with legends. Tales of swords that could slice a feather drifting through the air. Blades so sharp they could cut through a rifle barrel. Steel that never dulled, that flexed but never broke, that shimmered with a watery pattern like flowing smoke. These were not fantasies, but the famed weapons of Damascus, forged centuries ago in the heart of the Middle East, and feared and revered across continents. The secret of their making has been lost for hundreds of years, yet the legend of Damascus Steel remains very much alive. The term itself doesn't refer to a single forge or specific location, though it borrows the name of the ancient Syrian city that once stood at the crossroads of empires. Damascus became synonymous with excellence in sword-making, but the steel that bore its name likely originated much farther east, in the crucibles of India and Sri Lanka, where a material known as wood steel was first produced. This high-carbon steel, when cooled slowly and worked by skilled hands, resulted in blades of remarkable strength and flexibility. The craftsmen of the Islamic Golden Age, particularly from the 9th to 17th centuries, developed advanced forging techniques that transformed raw wood ingots into deadly and beautiful weapons. What made Damascus steel unique wasn't just its mechanical properties, but the patterns etched into its very grain. Swirling bands, waves, rosettes, each blade was like a fingerprint, its design the result of microscopic structures formed during forging. To modern metallurgists, these are known as carbide banding, layers of iron and carbon compounds arranged in fractal elegance. But to those who held the sword centuries ago, these patterns were signs of sorcery. How else to explain their superiority? These blades outperformed nearly everything Europe had to offer until the advent of industrial metallurgy. Crusaders who faced Muslim warriors in battle often returned home with stories of swords that seemed to defy logic. Not only were they sharper, but they held their edge after countless strikes. In time, even European blacksmiths tried to replicate the technique, but their attempts fell short. They could mimic the patterns with acid etching, but the performance of true Damascus steel eluded them. And then, mysteriously, it vanished. By the 18th century, the art of making true Damascus steel had faded into obscurity. The reasons remain unclear, though several factors likely played a role. The dwindling supply of high-quality wood ingots from India, the disruption of trade routes during colonial expansion, and the death of master smiths whose knowledge was never written down. It was a technology passed from hand to hand, from master to apprentice, in whispers and gestures, not in diagrams or textbooks. When the chain was broken, the knowledge evaporated. For over 2 centuries, metallurgists, historians, and hobbyists have tried to recover the ancient recipe. In the 20th century, researchers using electron microscopes discovered structures within surviving blades that resembled nanowires, incredibly fine arrangements of carbon nanotubes embedded in the steel. It seemed impossible. Could medieval smiths have accidentally created a form of nanotechnology? It's unlikely they understood it in modern terms, but they may have discovered, through patient repetition, that a certain sequence of heating, folding, and cooling produced a superior metal. What science now calls nanostructures, they might have called the soul of the blade. Attempts to recreate Damascus steel in modern laboratories have yielded some success. By analyzing the carbon content, the role of trace impurities like vanadium or molybdenum, and replicating ancient forging temperatures, metallurgists have managed to produce blades that resemble the old masterpieces, both in appearance and performance. And yet, something remains elusive. Even today, many consider true Damascus steel a lost art, not just a material but a philosophy of craftsmanship that cannot be industrialized or mechanized. The The story of Damascus Steel reminds us that not all progress is linear. Sometimes, humanity reaches heights only to forget how it got there. Knowledge can vanish, not with catastrophe, but with time, eroded by silence, by war, by the slow decay of tradition. We imagine ourselves as the most advanced generation in history, and in many ways we are. But when we look back at a blade from 1,000 years ago that performs better than modern alloys, we're reminded of a more humbling truth: that intelligence, ingenuity, and mastery have always existed. They simply took different forms. Damascus Steel was more than a weapon. It was a convergence of chemistry and intuition, of science and art, of empirical wisdom accumulated over generations. It lived in the fire of the forge, in the rhythm of the hammer, in the patience of hands that knew when to strike and when to wait. And when that lineage was broken, when the forges went cold, the steel passed into legend. But the legend endures. And perhaps that is enough for now to keep the spark alive. Roman concrete. Among the ruins of the ancient world, few things endure like Roman concrete. While steel bridges and modern highways crumble within decades, Roman harbors, aqueducts, and temples have stood the test of 2,000 years. Battered by waves, shaken by earthquakes, scorched by sun and time, and yet still defiantly intact. It is a silent triumph of engineering, buried in plain sight. And for centuries, the secret of its strength remained a mystery. Roman concrete, or opus cementitium, was not just ahead of its time. In many ways, it was better than what came after. At the heart of the Roman Empire's architectural ambition was a profound understanding of materials. While the Greeks built in marble and post and lintel forms, the Romans experimented with arches, vaults, and domes, geometries that demanded not only skill but a concrete capable of bearing new kinds of weight. What they created was more than a building material. It was a formula, a philosophy, and perhaps most astonishingly, a chemistry that modern science only began to understand in the 20th and 21st centuries. Unlike modern Portland cement, which is made by superheating limestone and other minerals to high temperatures, a process that emits large amounts of carbon dioxide, Roman concrete was made by mixing lime, calcium oxide, with volcanic ash, particularly the type found near the Bay of Naples. When mixed with seawater, this concoction didn't just harden. It underwent a kind of geological transformation. The material continued to strengthen over time, not degrade. Where modern concrete reacts poorly to salt water and develops cracks, Roman marine structures actually grew stronger the longer they were exposed to the ocean. This self-healing property fascinated modern researchers. For decades, Roman concrete was thought to be primitive, a rough mix of stone, sand, and lime, unsuited for the precision demands of modern construction. But the more closely it was studied, the more remarkable it appeared. Analysis of ancient Roman breakwaters revealed the presence of a rare mineral called aluminum tobermarite, a crystalline structure that forms slowly over time in the presence of seawater and volcanic ash. This mineral, which modern engineers struggle to synthesize under controlled conditions, forms naturally inside Roman concrete, bonding the material from within and increasing its durability over centuries. It was not an accident. Vitruvius, a Roman architect writing in the 1st century BCE, described the process in his treatises. The importance of sourcing the right ash, the benefits of mixing it with seawater, and the preference for specific ratios. The Romans may not have known the precise molecular mechanisms, but they observed, experimented, and refined. They noticed which structures endured and which failed. In the absence of modern chemistry, they followed a deeper kind of empirical science, one rooted in patient trial, apprenticeship, and long memory. And yet, as the empire fell, so too did the knowledge. The secrets of Roman concrete, passed orally from builder to builder, slowly dissolved into history. Later European architecture returned to stone masonry. When concrete was rediscovered in the 18th and 19th centuries, it bore little resemblance to its ancient predecessor. Our modern concrete, while easy to produce and fast to set, lacks the resilience of Roman formulations. Cracks, weathers, and crumbles. It requires constant repair, and it carries an immense environmental cost. In recent years, engineers and geologists have turned back to the past in search of answers. What if we could recreate Roman concrete, or even improve on it? What if the future of sustainable building lies not in some undiscovered polymer or alloy, but in the ashes of Mount Vesuvius? Teams of researchers have already begun to experiment with volcanic materials and lime-based binders. Some promising prototypes have been developed that mimic the self-healing properties of ancient Roman mix. In Iceland, in California, in Italy, volcanic ash is once again being studied as a key to longer-lasting infrastructure. But there is a deeper lesson embedded in the ruins. The Romans did not build for the short term. Their harbors, their roads, their temples. They were meant to last not decades but generations. There was no obsession with speed of construction or quarterly profits. There was pride in permanence. Roman concrete is not only an engineering achievement, it is a cultural one. It reflects a civilization that, despite all its flaws, believed in laying foundations that would outlive them. We tend to view the ancient world as simpler, less advanced, full of trial and superstition. But sometimes what we call primitive was simply a different kind of mastery born not from theory, but from centuries of observation, adaptation, and continuity. Roman concrete was not forgotten because it was inferior. It was lost because the knowledge chain broke, the needs of empire changed, and the memories faded. Now, as modern cities face decaying infrastructure and rising environmental costs, we find ourselves looking backward, toward formulas buried under centuries of dust, and wondering how a civilization so long gone could have built something we still struggle to equal. Perhaps the answer was always there, hardening slowly, quietly, in the ruins by the sea. Baghdad Battery. In the 1930s, amid the archaeological excavations near the village of Kujut Rabua, just outside Baghdad, a team of workers uncovered a curious object buried within a Parthian era site dating to around 250 BCE. It was unassuming at first glance, a clay jar about 14 centimeters tall. But inside the vessel lay a copper cylinder, and nestled within that, an iron rod, all sealed with bitumen. At first, it seemed like an odd piece of storage, perhaps a scroll case or a tool. But when Wilhelm Koenig, then director of the Baghdad Museum, examined it closely, he proposed something radical. This was not pottery, but a kind of ancient battery. A galvanic cell, made 2 millennia before electricity was ever formally discovered. The notion sounded outlandish. Electricity, after all, was the realm of modern science. Benjamin Franklin, Alessandro Volta, and Michael Faraday formed the bedrock of our understanding. The idea that ancient people, lacking any written theories of electromagnetism, any known electrical devices, or even a conceptual framework, might have stumbled upon the principles of electrochemistry seemed almost absurd. And yet, the physical structure of the so-called Baghdad Battery appeared to support it. A metal rod inside a metal cylinder, surrounded by an acidic liquid, could produce a small electric charge. And in modern tests, replicas filled with vinegar or lemon juice did just that, emitting between 0.5 to 1 volt of electricity. But the question was never whether it could work. It was why. No writings from the Parthians or surrounding cultures mention the use of electricity. There are no lamps, wires, or tools that seem powered by such cells.
No diagrams.
No secondary artifacts that could be interpreted as electrical circuits. If the Baghdad Battery was indeed a battery, it existed in isolation, a lonely spark in an otherwise dark field. And that contradiction has fascinated scientists, skeptics, and pseudo-historians alike. Some researchers have suggested that these vessels were used for electroplating, a process in which a thin layer of metal is deposited onto a surface using electric current. This idea is seductive. It implies a hidden technological capability, a kind of secret knowledge passed among artisans. Could ancient metalworkers have used electricity to gild statues or tools, to plate objects with precious metals more efficiently than hammering and fire? No direct evidence has been found, but it's a theory that refuses to die, precisely because the physical setup makes sense. A row of such devices could, in theory, be linked to produce enough current to carry out basic electrochemical tasks. Others believe the artifact may have had a ritual or symbolic function. The iron rod, for instance, might have been used to attract lightning or serve in some religious ceremony related to storm gods or purification. Perhaps the acidic liquid wasn't intended to generate electricity at all, but rather to preserve something, or to dissolve organic material over time. In this interpretation, the electrical properties are a side effect, a coincidence of materials rather than a deliberate invention. And then there are those who leap further, suggesting ancient alien contact, forgotten Atlantean knowledge, or a prehistoric technological civilization. These fringe theories, while popular in television documentaries and internet forums, often say more about modern fascination with lost knowledge than they do about the artifact itself. They fill the gaps in our understanding with imagination rather than evidence. But they also speak to something deeper, a yearning to believe that the ancients were more advanced than we give them credit for, that we are not the pinnacle but simply another link in a chain of forgotten brilliance. What makes the Baghdad Battery so compelling is its liminality. It exists in the narrow space between what we know and what we suspect. It is not sophisticated enough to definitively prove a lost science, nor mundane enough to be dismissed outright. It is just ambiguous enough to haunt the margins of history. Modern historians and archaeologists remain divided. Some believe the object was a simple storage jar, perhaps used for scrolls or sacred oils, and that the metallic elements served non-electrical purposes. Others maintain that while it may have produced a charge, there's no compelling reason to believe that the people who built it understood that charge or had any use for it. Even the terminology, calling it a battery, imposes a modern framework on an ancient artifact. It's possible, even likely, that we are asking the wrong questions. Yet the object remains, resting in museums and replicas across the world. Its shape, its materials, its stubborn refusal to explain itself. It serves as a mirror, reflecting not only what the Parthians may or may not have known, but also what we long to see in the past. A clue, connection, a reminder that history is rarely as linear as it seems. Whether a true battery or a misunderstood vessel, the artifact discovered near Baghdad continues to generate its own kind of energy, not electrical but intellectual. It provokes curiosity, it invites speculation, it asks us to reconsider the contours of technological evolution. Sometimes, it's the questions that matter more than the answers. And in the case of the Baghdad Battery, those questions still glow, faint and persistent, like a tiny spark sealed inside a jar. Vimanas. Across the vast landscape of ancient Indian epics, amid gods and demons, celestial wars and philosophical treatises, there exists a recurring and astonishing motif: flying machines. Known as Vimanas, these vehicles are described with poetic richness and technical curiosity in texts that are thousands of years old. Some move swiftly on beams of light, others hover motionless in the sky, and a few are said to travel between planets or dimensions. At first glance, they seem to belong entirely to myth, to the same realm as fire-breathing serpents and gods with multiple arms. And yet, there is something in the language, in the structure of the descriptions, that has led generations of readers and researchers to wonder. Were these stories purely symbolic, or were they fragments of something older, a technological memory preserved in sacred verse? The most famous mentions of Vimanas appear in texts like the Mahabharata, the Ramayana, and the Vaimanika Shastra. In the Ramayana, the Pushpaka Vimana is a massive aerial chariot, originally belonging to the demon king Ravana, which flies like the sun and changes its size to accommodate the will of its master. It is described as self-propelled, capable of both horizontal and vertical flight, and gliding with no visible means of propulsion. In the Mahabharata, gods and warriors ride in similar crafts during battles that play out in the skies like aerial duels. They are often equipped with weapons, not arrows or swords, but beams, flames, and sonic blasts. These descriptions, while poetic, often contain strangely technical details: geometric shapes, specific materials, and even power sources. Skeptics interpret Vimanas as metaphor. They argue that these vehicles were allegories for spiritual travel or poetic devices to elevate the scale of epic storytelling. Certainly, ancient texts from many cultures are rich in metaphor and symbolic layering. But in the case of Vimanas, the details sometimes seem too mechanical to ignore. In the Vaimanika Shastra, a Sanskrit treatise of uncertain origin that surfaced in the early 20th century, there are entire chapters describing the construction, control systems, pilot clothing, flight paths, and types of Vimanas, including diagrams. The text claims to be based on ancient knowledge passed down through sages, though modern scholars remain highly skeptical of its authenticity, often considering it a modern fabrication or reconstruction based on fragments of older mythologies. Still, the persistence of the idea is striking. Across centuries, through oral tradition and written verse, the Vimana remains not just a fantastical chariot of the gods, but a recurring image of human flight, conceived in a world thousands of years before the Wright brothers ever left the ground. Could it be that ancient Indian authors were projecting their desires for transcendence into mechanical visions? Or could they have been preserving the echo of some forgotten technology, something long since buried by time? There are theories, of course, some rooted in archaeology, others in the outer reaches of speculation. Fringe historians and ancient astronaut theorists have pointed to the Vimanas as potential evidence of extraterrestrial contact, suggesting that early humans may have witnessed flying machines and deified their operators. Others argue that there may have existed pre-cataclysmic civilizations with advanced technological capabilities, now erased from the archaeological record by floods, earthquakes, or the slow attrition of deep time. While mainstream academia finds little evidence for such claims, the Vimanas remain among the most provocative examples of anachronistic technology embedded in ancient literature. But perhaps the most compelling interpretation is more psychological than physical. The idea of flight, of lifting beyond the earth, has haunted the human imagination since our earliest stories. In the East, it took the form of flying chariots. In the West, of winged horses and Icarus-doomed descent. The Vimana could be seen not as proof of ancient machines, but as a testament to the universality of technological dreaming. Long before we had aluminum or jet fuel, we imagined machines that could lift us toward the stars. That vision, embedded in sacred verses and mythic battles, may say less about what the ancients built, and more about what they believed was possible. Yet, as ruins are unearthed and ancient texts are translated with new precision, the line between myth and memory continues to blur. There are temples carved with images that resemble rockets, inscriptions that speak of fiery engines, and oral traditions that describe sounds and movements strangely consistent with mechanical flight. Are these coincidences of language and imagination, or were they glimpses of something real, long forgotten? The Vimanas remain not as artifacts, but as ideas, timeless, weightless, suspended in the air between belief and doubt. Whether they were ever real in the physical sense is almost beside the point. They were real enough to be written down, passed on, and remembered. And in that remembering, they challenge us to look backward with curiosity, not certainty. Not all technology leaves wires and engines behind. Sometimes it leaves only a story, and sometimes that story travels farther than any machine. Nano-spirals of Ural Mountains. In the remote valleys of the Ural Mountains, where the rivers cut through ancient stone and the forests stretch untouched for miles, a quiet mystery lay buried beneath the earth. Unseen, undisturbed, and impossibly small. In the 1990s, as part of a routine geological survey near the Narada River in western Russia, researchers were collecting sediment samples in search of mineral resources. What they found instead were objects that should not have existed: microscopic spirals, coils, and metallic filaments, each no longer than a few millimeters, and yet manufactured with such precision that their origin defied explanation. These objects, later termed the nano-spirals of the Ural Mountains, were composed primarily of copper, tungsten, and molybdenum metals known for their conductivity, heat resistance, and use in aerospace engineering. But what made them truly remarkable wasn't their material. It was their form. Under electron microscopy, these particles revealed near-perfect geometrical structures. Spirals with consistent pitch, straight shafts with right-angle bends, and tubes hollowed with impossible symmetry. Some of them measured just a few micrometers in length, yet appeared machined, as if assembled with tools far more advanced than anything found at the excavation site. And then came the second shock: dating. The objects were found embedded in layers of sediment thousands of years old, some suggesting ages between 20,000 and 318,000 years. It was a timeline that didn't align with any known human activity, let alone with the precision manufacturing implied by the shapes. There were no settlements, no metallurgy, and certainly no nanotechnology in prehistoric Eurasia. And yet, there they were, tiny spirals nestled in ancient soil, challenging the chronology of technological progress. At first, the scientific community approached the findings with cautious curiosity. Some hypothesized that the objects might be industrial contamination, remnants of nearby mining activity, accidentally introduced into the samples. But this explanation didn't hold up under scrutiny. The surrounding region was largely untouched by heavy industry, and the sheer depth and age of the strata in which the spirals were discovered suggested natural burial over millennia, not recent pollution. Moreover, the structural precision of the objects, particularly those made of refractory metals like tungsten, pointed to manufacturing processes involving high temperatures and controlled environments, technologies well beyond what existed even a few centuries ago. Others suggested a natural origin. The spirals might be the byproduct of crystal growth, or a rare form of geological self-assembly. But metallurgists pushed back. The structures lacked the randomness typical of natural formations. Their uniformity, alignment, and repeated motifs hinted at intent, at design. Some researchers privately admitted what they could not publicly conclude, that the objects bore a closer resemblance to microcomponents of modern machines than to anything formed by chance. The mystery of the nanospirals quickly attracted a strange ecosystem of interest: scientists, ufologists, skeptics, and fringe theorists alike. Some saw in them the trace of a lost civilization, an ancient culture capable of engineering beyond our current reach, now erased by time or catastrophe. Others viewed them as evidence of extraterrestrial visitation, nanotechnological debris left behind by an unknown intelligence. These were wild hypotheses, unproven and often unsupported, but they captured something essential: the emotional gravity of the unexplained. For a time, the Russian Academy of Sciences launched a series of quiet investigations, analyzing the composition and morphology of the particles. The initial results were inconclusive. Without context, without associated artifacts, structures, or cultural evidence, the spirals remained isolated anomalies. Eventually, funding waned, interest faded, and the story slipped into obscurity. The samples were stored, scattered, or lost. Only a few micrographs and fragments remain as visual testimony. And yet, the question lingers. If these structures were not natural and not modern contamination, then who made them and when? Could they be remnants of some pre-human intelligence, an unknown branch of hominids with fleeting brilliance? Or are they reminders that technology is not always cumulative, that knowledge can bloom briefly, then vanish, buried under ice and soil? There is something deeply unsettling about the idea of forgotten science, of entire eras of understanding erased without trace. The nanospirals whisper of a possibility that the past may be more layered, more fragmented, and more cyclical than our linear histories suggest. Perhaps we are not the first to probe the very small, to explore the boundaries between material and design. Perhaps others came before, not gods or aliens but thinkers and builders now gone. In the silence of the Urals, the spirals remain, not as proof, but as puzzles. Too precise to dismiss, too disconnected to confirm. They occupy a strange threshold between geology and technology, between the ancient and the impossible. And whether they are the work of nature, of forgotten hands, or of something else entirely, they remind us that history still holds secrets small enough to fit on the head of a pin, and deep enough to shake what we think we know. Antikythera Mechanism. In the spring of 1900, off the coast of the small Greek island of Antikythera, a group of sponge divers descended into the Aegean Sea and stumbled upon a wreck that would rewrite history. Amid marble statues, amphorae, and fragments of bronze, they recovered a corroded, unrecognizable lump of metal and wood. At first, it looked like nothing more than encrusted debris, a forgotten part of some ship's cargo, disfigured by centuries underwater. But when the object was examined more closely, and later X-rayed, it revealed something astonishing. Inside the rusted mass were gears, dozens of them, interlocking, precise, deliberate. It would come to be known as the Antikythera Mechanism, and it would challenge everything we thought we knew about ancient technology. Dating back to around 150 BCE, the mechanism is now recognized as the oldest known analog computer, a device capable of modeling the motions of the sun, moon, and known planets with remarkable accuracy. Contained within a wooden case about the size of a shoebox, the machine originally held more than 30 bronze gears, each hand-cut and precisely meshed. When turned by a small crank, the gears moved in coordination, replicating the celestial cycles with astonishing elegance. It could predict eclipses, chart the position of heavenly bodies, and even account for the elliptical orbit of the moon, a detail that wouldn't be formally understood until many centuries later. For the modern mind, raised on the clean timeline of technological progress, the mechanism is deeply unsettling. Gearwork of such complexity wasn't thought to exist until the 14th century, in medieval European clocks. And yet here was a machine that predates those devices by over 1,000 years. Not crude, not experimental, but mature, purposeful, and brilliant. It was quite simply too advanced for its time. The question, of course, is how. How could such a device have been conceived, built, and understood in a world without electricity, precision machining, or calculus? The Greeks were no strangers to mathematics. Pythagoras, Archimedes, Hipparchus, and others laid the groundwork for geometry and astronomy. But the Antikythera Mechanism suggests more than theoretical knowledge. It points to a culture that translated abstract thought into moving parts, into mechanisms that could simulate the cosmos. Some scholars believe the device may have been influenced by the work of Archimedes himself. Others think it was constructed in Rhodes, a center of astronomical study and mechanical innovation during the Hellenistic period. But whoever made it, and however it came to rest at the bottom of the sea, one thing is certain: it was not unique by intention. The complexity of the mechanism implies a tradition, a lineage of makers and thinkers who had built and refined such devices over time. This was not the prototype of an invention. It was the product of a lost discipline. And that is perhaps the most haunting aspect of the Antikythera Mechanism. Not simply that it existed, but that it was forgotten. There are no other surviving examples. No texts describing its construction in detail. No mechanical treatises to explain its logic. After the fall of the Hellenistic world, the knowledge that created it vanished. For over a millennium, the West would not see anything like it again. The gears would sleep under centuries of sediment, and with them, the memory of a civilization capable of such extraordinary synthesis, science, engineering, and philosophy united in bronze. In recent decades, advanced imaging techniques, CT scanning, surface imaging, and 3D modeling have revealed more of the mechanism's secrets. Inscriptions once invisible have been translated, pointing to planetary cycles, eclipse predictions, and even the ancient Greek calendar. What emerges is not just a machine, but a cosmological statement. The universe as a system, knowable and predictable, mapped onto metal in the palm of the hand. Yet mysteries remain. Only about a third of the original device survives. Its exact functions, particularly on the lost front dial, are still debated. And the biggest mystery of all lingers: how many others once existed? Were there workshops producing these mechanisms? Were they tools for education, astrology, navigation? Or were they rare luxuries, the possessions of elite thinkers, like the coded notebooks of Da Vinci, lost to time? The Antikythera Mechanism is not just a marvel of ancient engineering. It is a rupture, a window into an alternate version of history in which the scientific revolution might have begun 2,000 years earlier. It forces us to question the linear story we tell about progress. From darkness to light, from ignorance to knowledge. Instead, it suggests something more fragile and circular, that knowledge can arise, burn brightly, and be extinguished. That brilliance is not the privilege of the modern world, but a recurring miracle. Today, the corroded gears of the Antikythera Mechanism sit behind glass, studied by teams of engineers, historians, and astronomers. They remain stubbornly silent, yet impossibly eloquent. Not just a relic, but a reminder that what we think of as impossible may have already been done, long ago and simply forgotten. Abydos Helicopter. On the sandstone walls of the Temple of Seti I in Abydos, deep in the heart of ancient Egypt, a single panel of hieroglyphs has stirred decades of fascination, debate, and controversy. High above the temple floor, among more conventional inscriptions, appears a set of carvings that, to the modern eye, seem startlingly out of place. They resemble unmistakably modern machines, what looks like a helicopter, a jet, even a tank. These images, etched over 3,000 years ago, have come to be known collectively as the Abydos Helicopter, and they have ignited one of the most enduring mysteries of ancient iconography. Discovered in the 20th century and popularized in photographs circulated across alternative history circles, the carvings appear too familiar to be dismissed. One shape seems to show a rotor blade and tail boom, much like a modern military helicopter. Next to it is a shape that resembles a jet or glider, another like a submarine or spacecraft. For many, especially those inclined to believe in hidden histories or ancient technological wisdom, this was more than symbolic art, it was evidence. Proof, perhaps, that ancient Egyptians had knowledge that transcended their time. Some took it further still, suggesting contact with advanced civilizations, lost human technology, or even extraterrestrial visitors who arrived in ships that were commemorated by the temple priests. Mainstream Egyptologists, however, have offered a different, and much more grounded explanation. According to them, the strange forms are the result of a well-understood phenomenon known as palimpsest, a situation in which inscriptions or carvings are overwritten or altered as new rulers modify old temples. In the case of Abydos, they argue, the original inscriptions were created under Pharaoh Seti I, and later altered during the reign of his son, Ramses II. Over time, as plaster eroded and the overlapping glyphs merged visually, they unintentionally formed shapes that resemble modern machinery. What we see in this view is an optical illusion born from layered language, a symbolic accident, not a technological revelation. This explanation, though rational and consistent with known Egyptian practices, has not silenced the fascination. Because even if the helicopter and jet are the result of coincidence, the precision and evocative nature of the images are difficult to ignore. The human mind is primed for pattern recognition. We see faces in clouds, animals in stars, and meaning in randomness. Perhaps that is all the Abydos carvings represent, the mind projecting familiarity onto the unfamiliar. But then again, what if that instinct is sometimes right? What if not every anachronism is a mistake? The question becomes more complex when considered in the broader context of Egyptian culture. The civilization of the Nile was astonishing in its achievements. Grand architecture, advanced astronomy, surgical instruments, sophisticated mathematics, and a written language that endured for thousands of years. They built pyramids that aligned with stars, mapped celestial cycles, and preserved the human body with techniques we only recently began to understand fully. Could such a culture have known more than we credit them for? Could certain ideas, flights of technological imagination, have existed symbolically, spiritually, or even practically only to vanish without trace? There are no records, no tools, no engineering plans that suggest the ancient Egyptians ever built machines that flew through the air or moved on treads. And yet the helicopter persists, not as a fact but as a suggestion, a question carved into stone. It represents the space where archaeology meets mythology, where science shades into wonder, not because it proves anything conclusively, but because it reminds us how easily we fill the unknown with our hopes and fears, our myths and projections. The Abydos helicopter sits at the crossroads of belief and skepticism. To some, it is irrefutable evidence of lost knowledge. To others, an amusing coincidence misinterpreted through the lens of modern bias. But what cannot be denied is its effect. It invites us to look again, to reconsider what we think we know, and to entertain the possibility that history may still hold secrets not yet uncovered. Perhaps it is not a helicopter at all, merely the ghost of a glyph, eroded by time and imagination. Or perhaps it is something older, something remembered not in technology, but in symbol, a dream of flight carved long before it was possible, a premonition in stone. Whatever it is, it remains suspended above us on the wall of a temple built for gods and kings, watching silently across millennia, offering no answers, only the invitation to wonder. Quimbaya artifacts. In the lush valleys of what is now Colombia, long before European ships ever touched the shores of South America, the Quimbaya civilization thrived. Known for their exceptional artistry and masterful metalwork, the Quimbaya people left behind a legacy in gold, hundreds of exquisite artifacts crafted with stunning precision. Among their most famous creations are the so-called Quimbaya artifacts, also known as the Quimbaya airplanes, a collection of small, golden objects dated to between 500 and 800 CE. To the trained eye of an archaeologist, they appear to be stylized representations of birds or insects. But to the modern viewer, they suggest something far more astonishing: aircraft. These gold figurines, no more than a few inches long, have wings, upright tails, and fuselage-like bodies. Some even have what appear to be rudders and landing gear. Their resemblance to modern delta-wing jets is uncanny, enough to launch decades of speculation, debate, and alternative theories. Could these be ancient models of flying machines? So, who made them and why? The Quimbaya artifacts belong to a broader category of pre-Columbian goldwork known as tumbaga, an alloy of gold and copper that was both easy to shape and capable of capturing fine detail. These objects were likely used in rituals or buried with the dead as offerings to the gods. But the handful that look like miniature aircraft stand out from the rest. Unlike most animal motifs found in Quimbaya goldwork, which clearly depict frogs, bats, or birds, these few objects defy easy classification. They have flat, triangular wings, perpendicular to the body, and symmetrical tails, elements not typically found in nature, but common in engineered flight. In the 1990s, German researchers and aviation enthusiasts Peter Belting and Algund Ibum took this theory to a bold new level. They constructed scaled-up models of the Quimbaya airplanes, equipped them with engines, and, astonishingly, got them to fly. The aerodynamic properties were functional. The models, built to modern flight standards, took off, glided, and landed. This practical demonstration, they argued, proved the original artifacts were not merely symbolic or decorative, but representations of real, flying technology. But the question remained: how could an ancient South American culture possess knowledge of aerodynamics more than a millennium before the Wright brothers? Mainstream archaeologists offered more grounded explanations. The forms, they said, could simply be stylized interpretations of birds or insects, rendered abstractly in the artistic conventions of the time. The Quimbaya were artisans, not engineers, and their creations should not be projected through a modern technological lens. To assume otherwise risks imposing our own concepts onto a culture that had no word for airplane. No machines, no writing, only gold and myth. But even within that skepticism, there lingers a sense of curiosity. Because the Quimbaya artifacts do not just mimic birds, they omit organic features like eyes, feathers, or legs. Instead, they emphasize symmetry, geometry, and form. The precision is intentional. Some theorists suggest that if not inspired by real aircraft, the designs could have emerged from visionary experiences, dreams, hallucinogenic rituals, or mythic storytelling. Perhaps these were not models of real machines, but rather symbols of gods or spirits who flew, carried across the skies by wind and will. South American legends are rich with stories of flying beings. Sky serpents, thunderbirds, gods who descended from above. The Nazca lines in Peru, visible only from the sky, have similarly stoked theories of ancient flight. Could the Quimbaya airplanes be part of that same symbolic language? Representations of beings that moved between the heavens and the earth, rendered in the only materials they had to preserve such visions: gold. In this view, the artifacts become a bridge between art and mystery. They remind us that technology is not always made of wires and engines. It can live in dreams and metaphor. The gold figurines may never have flown in the literal sense, but they still soar in the imagination, pulling us toward possibilities beyond our current understanding. And so they remain, glinting quietly in glass museum cases, relics of a civilization long vanished, yet still speaking. Whether they are birds, symbols, or models of forgotten machines, they testify to a human instinct that transcends time and culture. The desire to rise, to move through the air, to leave the earth behind, if only in thought. The Quimbaya may not have had airplanes, but they imagined something that flies. And sometimes, imagination is the very first engine. Crystal skulls. In museum cases, private collections, and dusty archives around the world, there exists a series of artifacts that shimmer with mystery, carved entirely from clear or milky quartz, shaped with uncanny precision into the form of human skulls. These are the infamous crystal skulls, objects that have fascinated archaeologists, mystics, and conspiracy theorists alike for over a century. They seem too perfect, too detailed, too technologically advanced for the ancient worlds from which they supposedly came. And in that tension between artifact and anomaly lies a story that refuses to be fully explained. Most of these skulls surfaced in the 19th and early 20th centuries, often claimed to be relics from ancient Mesoamerican civilizations such as the Maya or Aztecs. But unlike other archaeological discoveries that emerged from carefully excavated sites, the crystal skulls tend to appear under murky circumstances, through private dealers, shadowy collectors, and colonial expeditions. The most famous among them is the so-called Mitchell Hedges skull, a life-sized quartz crystal artifact with astonishing anatomical detail. It was allegedly discovered in 1924 by Anna Mitchell Hedges, the adopted daughter of British adventurer F.A. Mitchell Hedges, during an expedition to the ruins of Lebanton in Belize. But no official record of the discovery was ever documented, and the skull itself didn't appear in public until decades later. What makes these skulls so remarkable is not just their form. It's the precision with which they were made. The Mitchell Hedges skull, for instance, includes a detachable jaw, smooth curvature, and optical qualities that defy simple hand carving. According to early studies by engineers and art historians, the skull was supposedly fashioned against the grain of the quartz crystal, meaning any modern carving method using rotary tools would have risked shattering the entire piece. This led to the widespread claim that no known technology, even in the 20th century, could have produced such an object without modern equipment, let alone ancient tools made of obsidian or copper. This idea spawned a wave of speculation. Some claimed the skulls were left behind by a long-lost civilization, like Atlantis. Others suggested extraterrestrial origins, alien artifacts brought to Earth as gifts or warnings. New Age interpretations flourished in the 1980s and 1990s, proposing that the skulls were repositories of ancient wisdom, capable of storing consciousness, transmitting energy, or unlocking hidden truths about human history. Stories circulated that there were exactly 13 crystal skulls, each holding a key to understanding our collective past and spiritual future, and that only when reunited could they save the world from catastrophe. Yet, when examined under modern scientific scrutiny, many of the skulls show telltale signs of recent manufacture. Microscopic analysis has revealed marks from rotary wheels and diamond-tipped carving tools, suggesting fabrication in the late 19th or even 20th century. Some experts trace the skulls back to workshops in Germany, particularly in the town crystal skulls. In museum cases, private collections, and dusty archives around the world, there exists a series of artifacts that shimmer with mystery, carved entirely from clear or milky quartz, shaped with uncanny precision into the form of human skulls. These are the infamous crystal skulls, objects that have fascinated archaeologists, mystics, and conspiracy theorists alike for over a century. They seem too perfect, too detailed, too technologically advanced for the ancient worlds from which they supposedly came. And in that tension between artifact and anomaly lies a story that refuses to be fully explained. Most of these skulls surfaced in the 19th and early 20th centuries, often claimed to be relics from ancient Mesoamerican civilizations such as the Maya or Aztecs. But unlike other archaeological discoveries that emerged from carefully excavated sites, the crystal skulls tend to appear under murky circumstances, through private dealers, shadowy collectors, and colonial expeditions. The most famous among them is the so-called Mitchell Hedges skull, a life-sized quartz crystal artifact with astonishing anatomical detail. It was allegedly discovered in 1924 by Anna Mitchell Hedges, the adopted daughter of British adventurer F.A. Mitchell Hedges, during an expedition to the ruins of Lebanton in Belize. But no official record of the discovery was ever documented, and the skull itself didn't appear in public until decades later. What makes these skulls so remarkable is not just their form. It's the precision with which they were made. The Mitchell Hedges skull, for instance, includes a detachable jaw. Piri Reis Map. In 1929, as Turkish historians sifted through the dusty relics of the old imperial palace in Istanbul, they came across a rolled piece of gazelle skin parchment, yellowed with age, marked with strange script and delicate colors. What they had found would become one of the most mysterious and hotly debated artifacts of cartographic history. The Piri Reis Map, dated to 1513. Its creator was an Ottoman admiral and cartographer named Ahmed Muhyiddin Piri, known today as Piri Reis, and his map would not just chart the known world of the early 16th century. It would challenge our understanding of what the ancients may have known long before satellites and global positioning. At first glance, the map seems ordinary for its time. It depicts the western coast of Africa, the eastern coast of South America, and even parts of the Atlantic archipelagos with remarkable accuracy. But as experts began analyzing its contents more closely, they found strange anomalies, features that did not match the geography known to the Ottoman Empire or even to European navigators of that age. What drew the most attention was the bottom edge of the map, a landmass resembling the northern coast of Antarctica, not as it is now, buried beneath miles of ice, but as it might appear ice-free, revealing mountain ranges and rivers invisible to modern instruments until the mid-20th century. But how could a map created in 1513 depict a continent that was officially discovered in 1820? And more perplexingly, how could it show what lay beneath the Antarctic ice sheet, something humanity wouldn't confirm until seismic radar mapping in the 1950s? According to Piri Reis's own notes, scribbled in the margins of the map, he did not draw it from direct observation. Instead, he compiled it using about 20 earlier source maps, some from Portuguese and Arabic explorers, others from ancient Greek and even possibly Alexandrian origins. Among these, he claimed, were maps drawn in the time of Alexander the Great, and others that were very ancient. This admission fueled speculation that Piri Reis had inherited fragments of a lost knowledge, perhaps originating from long-lost civilizations or unknown mariners who had mapped the globe with a precision that seemed to defy their era. Scholars and theorists alike began to speculate. Some suggested that the map could be evidence of a now-lost global seafaring culture, one that existed before the rise of known empires. Others hinted at Atlantean origins or even extraterrestrial influence. Supporters of the ancient advanced civilization hypothesis argued that the accuracy of the South American coastline and the detailed inland rivers and mountain ranges were too precise to have come from 16th century observation alone. The map even appeared to represent longitudinal data, a feat not possible until the invention of accurate timekeeping devices centuries later. Skeptics, however, argued that much of the map's accuracy was overstated or misinterpreted. What some saw as Antarctica, they said, could simply be a misrepresentation of the southern part of South America, distorted due to the map's projection. The map, after all, is not a modern rendering. It's drawn in portolan style, emphasizing coastal outlines and navigational use, not true geodetic geometry. The supposed ice-free Antarctic coastline might simply be coincidental or a product of artistic interpretation, not advanced geophysical knowledge. Yet even critics couldn't explain away all the anomalies. The map included regions of South America that had not yet been explored by Europeans in 1513, particularly deep into the Amazon basin. It also correctly showed the relative positions of Africa and South America across the vast Atlantic, in a way that modern geographers only confirmed centuries later. The level of detail suggests not just a gifted artist or sailor, but a compiler of deeply rooted knowledge, a mapmaker working at the intersection of multiple civilizations, drawing upon data passed down through forgotten routes of time. To some, the Piri Reis Map remains a testament to the underestimated capabilities of ancient mariners. To others, it's a tantalizing artifact, a relic of a history we may have only partially uncovered. Its existence forces us to confront uncomfortable questions. What knowledge has been lost to war, conquest, and time? Who were the true mapmakers of the ancient world, and how far did they really travel? The gazelle-skin parchment now rests in the Topkapi Palace Museum, behind glass, its faded ink a quiet reminder that history is never as complete as we think. The Piri Reis Map stands at the border between the known and the unknown, a symbolic coastline of its own, suggesting that the true edges of our understanding might still lie just beyond the visible horizon. Geopolymer. In the arid heat of Egypt and the misty jungles of Mesoamerica, colossal stone structures rise from the dust, monuments that have withstood the erosion of time, the collapse of empires, and the disbelief of generations. The pyramids of Giza, the megaliths of Baalbek, the giant blocks of Tiwanaku, all share something in common: impossible scale and uncanny precision. For centuries, conventional wisdom has held that these monuments were carved, hauled, and stacked with brute force, rudimentary tools, and staggering manpower. But a different possibility whispers beneath the stone. What if, rather than being carved, some of these stones were cast? This idea is not new, but it has gained renewed attention under a single controversial term: geopolymer. Coined by French materials scientist Joseph Davidovits in the 1970s, geopolymer refers to a synthetic, stone-like material created through a process resembling modern concrete, but using natural minerals, not cement. According to Davidovits, ancient builders might not have moved massive stones at all. Instead, they could have created them in place, pouring a reconstituted stone slurry into molds, allowing it to harden into seamless blocks with precise angles and interlocking joints. In other words, these megalithic structures might not be hewn from mountains, they might be a kind of lost concrete. The implications are profound. If correct, this would mean that thousands of years before Portland cement and industrial kilns, ancient civilizations had developed their own form of advanced materials science, a chemistry of stone that we are only now beginning to rediscover. Supporters of the theory point to blocks in the Great Pyramid of Giza that contain fossilized shells and air bubbles, or to L-shaped joins between stones that defy the logic of traditional masonry. They cite the seamless joints at sites like Pumapunku, where 100-ton stones seem to have been fused together like puzzle pieces. Some blocks exhibit internal structures inconsistent with natural quarrying, as if formed under different conditions entirely, not cut from the earth but synthesized. Critics, of course, remain skeptical. Traditional archaeologists maintain that all known evidence supports conventional stone carving techniques: copper chisels, dolerite pounders, sledges, and skilled labor. They argue that the presence of microfossils or irregularities in the stone can be explained geologically. The geopolymer hypothesis, they say, underestimates the ingenuity and endurance of ancient workers and overstates the anomalies in construction. And yet, the questions persist. Why would ancient builders drag stones weighing hundreds of tons when similar structures could be achieved more easily by pouring materials into molds? Why do certain structures appear to have been built with methods that contradict the limitations of the tools known at the time? And why, in some cases, do the stones seem to conform to each other in ways that suggest they were molded in place rather than placed individually? More curiously, geopolymers are not science fiction. Modern materials engineers have successfully replicated the process using only natural ingredients available to ancient civilizations: kaolinite clay, limestone, alkaline solutions. The resulting stone is virtually indistinguishable from natural rock and, in some cases, even more durable. These synthetic stones don't just mimic ancient techniques, they validate the very possibility that such methods were once known and then forgotten. The geopolymer theory doesn't claim to rewrite all of history. It doesn't dismiss the monumental effort of human labor, the grandeur of ancient vision, or the brilliance of architectural planning. But it does invite us to reconsider the methods, to entertain the possibility that ancient civilizations understood material science in ways that we're only beginning to appreciate. Perhaps the most unsettling aspect is that if such technology existed, it was lost. Lost in the fires of conquest, in the decay of time, in the silence of unwritten traditions. Lost so thoroughly that its rediscovery in modern laboratories feels more like reverse engineering than invention. The stones remain, silent, vast, and unmoved, but the method by which they came into being may be the echo of an ancient chemistry now obscured by sand and skepticism. Like the formula for Greek fire, like the tempered glass of Roman cups, like the glint of Damascus steel, geopolymer may represent yet another fragment of a forgotten science, not too advanced for its time, but too advanced for ours to easily accept. And as we touch the cold surface of these monuments, we are not just brushing stone. We are feeling the hardened shadow of a knowledge we may have once known, and might one day reclaim. Harrapan gear artifacts. Beneath the layers of silt and silence in the vast plains of the Indus Valley, an ancient civilization once flourished in structured elegance: the Harrapans. They built cities aligned to cardinal directions, mastered drainage systems, and standardized weights and measures long before Rome or Athens were born. And yet, despite their complexity, they left behind no decipherable written history, only the fragments of their world, unearthed brick by brick. Among these fragments, researchers discovered something strange, artifacts so oddly shaped, they seemed out of place, out of time. Metallic objects, often circular, with evenly spaced notches around their edges. Artifacts that looked undeniably like gears. At first glance, these pieces could be dismissed as decorative tokens or ritualistic items. But their precise geometry, symmetric patterns, and mechanical resemblance resist such easy categorization. Found in sites such as Mohenjo-Daro and Harappa itself, these gear-like objects sparked curiosity among archaeologists and alternative researchers alike. Their appearance conjured images of cogs in a forgotten machine, machines that, according to the established timeline of history, simply could not have existed at the time. The Harappan civilization peaked between 2600 and 1900 BCE, during the Bronze Age, a time when metallurgy was young and mechanized technology, as we understand it, had not yet emerged. The gear, as a concept, wouldn't be formally described until thousands of years later in Hellenistic Greece. Yet here, seemingly out of place, were shapes that mimicked interlocking wheels and transmission components, the very hallmarks of mechanical systems. Some of the artifacts are made of bronze or copper alloys, shaped into discs with equidistant teeth and central holes, suggesting they could have been mounted, rotated, or used in conjunction with other pieces. Their sizes vary, from small coin-sized components to larger discs that would not be out of place in early machines. The craftsmanship is deliberate, and the consistency of their features hints at more than coincidence. What were these objects for? Conventional explanations abound. Some archaeologists believe they may have served as spindle whorls, weights used in the process of spinning thread, where balanced rotation is essential. Others suggest they might have been used in religious ceremonies or served as symbolic representations of the cosmos or celestial wheels. Perhaps they were tokens, seals, or ornaments, whose resemblance to gears is only incidental, an illusion formed by our modern, machine-saturated perspective. But then there are other anomalies. Harappan artifacts also include depictions of wheeled transport, standardized tools, and even evidence of early surveying methods. The civilization was technically adept, capable of high-precision work in stone, metal, and ceramics. Some researchers point to the advanced water management systems, featuring sluices, tanks, and gradients, as evidence of applied engineering knowledge. If the Harappans understood hydrodynamics and urban planning, could they also have explored mechanisms more sophisticated than we currently believe? The theory that these gear-like objects were part of a mechanical device, perhaps a calendrical tool, an astronomical model, or even an early timekeeping instrument, remains speculative. But not impossible. In fact, history has shown us that the unexpected often hides in the past. The Antikythera Mechanism of ancient Greece, with its interlocking bronze gears, was also once thought to be an anachronism until it wasn't. Unlike the Greeks, however, the Harappans left no written manuals, no descriptive records. Their language remains undeciphered, their intentions locked behind seals and pictographs that refuse to yield their meaning. Without context, the gear artifacts become riddles, mute and durable, their purpose suspended between the sacred and the mechanical. Some propose that if they were indeed mechanical, the Harappans may have been on the cusp of a technological awakening, one that was abruptly extinguished by environmental collapse, migration, or war. Others suggest these gears are the remnants of knowledge passed down from an even older, unknown civilization, perhaps one erased by time, remembered only in the fragments that occasionally surface in unexpected places. It's tempting to weave legends into the gaps, to imagine machines turning in the workshops of Mohenjo-Daro, or celestial models tracking lunar cycles while the rest of the world still marked time by shadows. Perhaps these were the first hints of a mechanical tradition that never took root, a path not followed, a history that forked and then disappeared. Today, the gear artifacts lie in museums, tagged and catalogued, but not truly understood. They remain quiet provocations, beckoning us to reconsider our assumptions. In their teeth and curves, they carry not just the shape of machinery, but the shape of a mystery, a glimpse into an intelligence that looked at materials and forms, and perhaps, just perhaps, glimpsed the potential of motion, of mechanism, of precision. The Harrapans left no voice, but their artifacts might still whisper. Tesla Cave Theory. In the shadowy intersection of science and myth, few figures are as magnetically enigmatic as Nikola Tesla, a man whose inventions shaped the modern world, alternating current, wireless communication, and even early robotics. Tesla remains a symbol of genius unbounded by his time. But for all his verifiable contributions, whispers of hidden experiments and forgotten knowledge continue to swirl around his name. Among the most tantalizing of these is the so-called Tesla Cave Theory, the notion that Tesla, at some point in his life, conducted secret experiments deep underground, tapping into the Earth's natural energies in pursuit of a limitless power source. There is no official paper, no patent, no blueprint that directly confirms the theory. But the breadcrumbs are there, scattered in letters, rumors, lost notebooks, and strange coincidences. According to this hypothesis, Tesla believed the Earth itself was not just a passive sphere of rock, but a dynamic conductor, pulsing with electromagnetic resonance, natural harmonics, and untapped potential. And in order to access this energy most efficiently, he allegedly sought isolation in subterranean environments, where interference from man-made signals and solar radiation could be minimized. Some versions of the theory point to a cave system near Colorado Springs, where Tesla famously conducted experiments with his magnifying transmitter, a device capable of generating millions of volts and lighting lamps wirelessly from a distance. Others suggest hidden tunnels below his Wardenclyffe Tower on Long Island, which was meant to transmit wireless electricity across the planet. There are even accounts, often unverifiable, of Tesla disappearing for days, re-emerging gaunt and silent, claiming to have heard the planet breathing. Those who believe in the cave theory claim Tesla may have used the Earth's strata as a natural amplifier, channeling resonance frequencies through quartz-lined tunnels or mineral-rich caverns. The idea wasn't entirely unfounded. Tesla did speak openly about the Earth having a resonant frequency, which modern science would later confirm as the Schumann resonance, a low-frequency electromagnetic pulse generated by lightning and trapped between the Earth's surface and the ionosphere. But where modern science sees background noise, Tesla saw opportunity. What if, he wondered, energy could be transmitted through the Earth itself? Not through wires but through vibrational harmonics, the way a tuning fork sets another into motion from a distance. His Colorado Springs experiments involved massive Tesla coils sending artificial lightning into the ground, and he reported strange phenomena. Lights glowing without wires, instruments behaving erratically, and a strange humming in the Earth. Tesla once cryptically wrote, "If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration." That phrase has become the mantra of modern mystics, but to Tesla it was likely a literal belief. The cave theory builds on this, suggesting that deep underground, he believed he could isolate the Earth's core frequencies and harness them. Some even claim he sought to develop a global energy grid powered not by coal or oil, but by the natural hum of the planet, pure, clean, and infinite. There are, of course, no photographs of Tesla in a cave. No schematics detailing such experiments. What exists are fragments. Journals that have gone missing, blueprints seized by government agencies after his death, and vague statements made late in his life, where he spoke of creating a machine that could split the Earth like an apple or send limitless power to the other side of the globe. Skeptics dismiss the cave theory as fantasy, the product of conspiracy enthusiasts and misread diary entries. But Tesla's own life invites such speculation. He was a man perpetually on the edge of invention, of poverty, of brilliance. He walked between two worlds, one grounded in engineering, the other in dreams of cosmic machinery and death rays. For every invention he built, there were a dozen he merely described, sometimes in language more poetic than technical. The Tesla cave theory, whether real or imagined, is ultimately not about a literal hole in the Earth. It is a metaphor for the spaces he explored that the rest of the world was not yet ready to enter. It speaks to the idea that knowledge might exist in hidden places, not only in dusty libraries, but in forgotten chambers beneath our feet, humming with unseen forces. Today, the cave theory lingers like an underground current. Some search for physical entrances, old mining tunnels, sealed basements, or anomalies in geologic surveys. Others chase the idea itself, building devices inspired by Tesla's resonance theories, hoping to awaken something long dormant. Whether Tesla actually descended into caves to tap the Earth's pulse may never be confirmed. But in a deeper sense, he was always there, tunneling through the unknown, alone with the frequencies only he could hear. Dendera Light. In the quiet chambers beneath the Temple of Hathor in Dendera, Egypt, carved deep into the stone walls of an underground crypt, lies an image that has ignited decades of speculation. It shows what appears to be a large bulbous object, connected by a thick cable to a box held by a figure crouched like an electrician at work. Emerging from the bulb is a serpent, its body coiled inside the glass-like shape, while other figures appear to support or gesture toward the strange device. To the casual observer, it may seem like nothing more than ancient symbolism. But to others, the depiction is something far more provocative, evidence of lost technology, a device that some have come to call the Dendera Light. For many mainstream Egyptologists, the carvings are simply religious iconography, symbolic representations of the creation myth, the lotus flower, the primordial serpent, and the pillars of the sky. But the image's uncanny resemblance to modern electrical components is difficult to ignore. The bulb bears striking similarity to a Crookes tube or early cathode ray tube, the type used in early experiments with electricity and X-rays. The cable looks suspiciously like a power cord, and the box resembles a generator or some form of energy source. Even the serpent, thought to represent divine energy in mythology, emerges from the object like plasma within a gas discharge tube. The first serious modern reference to this theory came from a 20th-century electrical engineer who, upon seeing photographs of the carving, immediately saw what looked like a vacuum tube. To someone trained in the manipulation of electrons, the shape, the orientation, and the associated figures made technical, not symbolic sense. Could it be, they asked, that the ancient Egyptians understood electricity? Could they have engineered a form of lighting that predated our rediscovery of it by millennia? Supporters of the theory point to the absence of soot on the ceilings of tombs and passageways, long, twisting halls filled with intricate paintings and inscriptions, but no apparent ventilation or torch burns. How did they see in such darkness, deep within the earth? Mirrors, some say, but others argue that mirrors would have been inefficient and degraded light rapidly. Could they have used electric illumination? Some have even attempted to reconstruct the Dendera Light based on the carvings. Using basic vacuum tubes, copper coils, and inert gases, experimental archaeologists have managed to create devices that do emit light when a current is passed through them, glowing eerily like the serpent trapped inside the ancient bulb. These replications are far from proof, but they show that the geometry of the carving is at least plausible as a kind of primitive electrical apparatus. Yet, for all the intrigue, no physical artifacts have been found. No wires, no filaments, no batteries, unless of course one points to the mysterious Baghdad Battery, a separate anomaly in the archaeological record. And even if the Dendera Light were a symbolic depiction of real technology, it begs the question, where did that knowledge go? Why is there no trace of a broader electrical system in ancient Egypt? Why only one carving, hidden deep in an obscure temple? The answers may lie in the very nature of ancient knowledge, often encoded in symbols, passed through rituals, and jealously guarded by priesthoods. If the Dendera Light was real, it may have been sacred, experimental, or restricted to a small elite. Or perhaps it wasn't a technology in the physical sense at all, but a conceptual tool, an ancient visualization of spiritual illumination, of divine energy channeled into matter. Still, the carving persists, etched in stone, immune to time or interpretation. It watches silently from the sandstone wall, inviting both scientists and dreamers to wonder. What if the ancient world knew more than we think? What if the Dendera Light is a remnant of a forgotten chapter in human ingenuity, a moment when myth and mechanics were one and the same? In that flicker of possibility, the temple remains not just a monument to the past, but a question directed at the future. A riddle carved in stone, waiting for light to be shed upon it, whether by torch, bulb, or something stranger still. Ending. Knowledge, ancient genius, or perhaps something even more mysterious. Were these the relics of forgotten civilizations? Or are we simply projecting our modern understanding onto the shadows of the past? We'd love to hear your thoughts. Share your theories in the comments, whether you believe in the possibility of ancient high-tech, or you think there's a more grounded explanation behind it all. If you enjoyed this journey through time and mystery, make sure to leave a like, subscribe to the channel, and ring the bell so you won't miss the next episode. And if you know someone who's fascinated by the unknown, share this video with them. The past is full of riddles. Let's solve them together. Until next time.